So, because what I'm interested in is the chemistry you need to do biology, I'm going to do just the chemistry you need. And so we're going to limit our discussion. So this is the atoms for Bio 111. There's 103 different kinds of atoms, 106. They keep adding more. We're only going to worry about a couple. H, hydrogen, C, carbon, N, nitrogen, O, oxygen, S, sulfur, and P, phosphorus. The big six, right? They're 99.9% of the atoms in your body are one or another, or one, it can't be another, are one of those kinds, right? So, again, when you take chemistry, there's going to be a lot more atoms to worry about. We're only going to worry about these. Bonds in Bio 111 are covalent and non-covalent. And the non-covalent can be what we call ionic, as somebody asked about a second. Also you might have heard of those things called electrostatic bonds. There are hydrogen bonds. There are van der Waals. And then the last, many of you may have heard of these, and the last one you may not have heard about is something called the hydrophobic interaction, which turns out to be enormously important in biology, and it's probably something you haven't heard about, and so we'll spend a bunch of time fussing about that. So you got your covalent and you got your non-covalent bonds. So molecules are held together with these molecules, these glue individual molecules to themselves. These bonds hold one molecule to the next. All right. So how will we use chemistry? So all the stuff in Bio 111 is about what can you do with what you know. So I could give you just a set of rules, and in fact later on the handouts there's a set of rules for working with these things. But I want to explain a little bit of where they come from, because it helps people understand them better to know where it comes from. So that's what today's about. The other thing is, today especially, and a little bit more on Friday, I'm going to be talking about stuff, and you're going to be saying, why should I possibly care about this? And what I have to do is you have to grant me that you'll see why it's worth caring about that in a few days when we sort of put it on. So I got to lay some stuff out now that will seem sort of weird and obscure and confusing, and in a couple days I get to deliver on why it's actually useful and was worth learning. So basically the goal is to predict molecular properties. The idea is, looking at those molecules, what can you predict about how they're going to behave? And there's some rules for that. Is that atomic structure, and specifically the outer shell electrons, let me write that out, electrons, they're abbreviated E minus because they have a negative charge, they predict two things. A, the bonding within molecules, that is covalent, bless you, and bonding between molecules, and that's non-covalent. Okay. So the thing is, today's the last day we're ever going to care about protons and neutrons and the stuff inside the nucleus. In fact, All we're really going to care about is the outer shell electrons. Inner shell electrons in nucleus, not our problem as far as biology is concerned. If you're a physicist or a chemist, you're going to worry about those. We're going to take just the big picture view because that's all you really need to know to do this. And it's not because I don't think you guys are up to speed. We could certainly do serious chemistry in here. It's just a matter of I want to spend time talking about biology, not chemistry, as best I can. So a couple things. 1A above determines the shape of molecules. We'll learn about that and how the shape of molecules is determined. And 2, second rule, is that bonding plus shape determines molecular properties. Okay. And so it's like people ask there about there. It's all people said it's all about the bonds. That's how it determines everything that we're going to be talking about here. And again, to go back to outer shell electrons are really important. They're why you don't fall through your seat, right? The reason you sit on the seat and don't just pass right through it, even though your atoms are mostly empty space, is because you have outer shell electrons in your atoms are negatively charged, and they come up against the outer shell electrons of the atoms in the seat, and they repel each other, right? And so they don't. That's why you don't sink through the seat, why you can walk on the floor, a variety of things. So they're really important and sort of worth talking about in a bunch of detail.